This program is brought to you by the Ministry of Education and Vocational Training Zanzibar in collaboration with Good Neighbors. The program is funded by COICA.
Dear listener, you may learn useful concepts of physics in this program as far as you will pay your attention to listen. However, our program today is specially for Form 2 physics learners. The program will provide free discussion on A. The concept of linear momentum. The concept of linear momentum. B. Determination on linear momentum. Determination on linear momentum. C. The verification of Newton's second law of motion. The verification of Newton's second law of motion. Self-assessment is allowed while the program is going on. For our lovely teacher, this program will help you to prepare a simple lesson for your students so that they will learn with joy, improve their performance and competence.
Oh, welcome and get in.
Thank you, madam. How do you do?
I'm okay. Have a seat, please.
Thank you.
Feel at home. Today I have a quiz for you. Are you ready?
Yes.
We are ready, madam. Very interesting because I like quiz.
So I will ask a question.
Okay.
And who raises the hand first will get the chance to answer.
All right.
If you give the right answer, I'll give you 2 marks.
Wow.
Yeah. But if you give the wrong answer or remain silent, I will ring the bell for you. Can we start?
Yes.
Before starting, our quiz is based on the discussion we did about the Newton's laws of motion.
Okay, madam. But the discussion was only about the second law of motion.
Excellent. And our quiz will also focus on the second law of motion. So listen very careful, okay?
Yes, madam.
Okay.
Anything that has mass and occupies space. What is it? And give one example. Yes, Musa?
That is matter. And an example is a ball.
Excellent.
Thank you.
Anything that has mass and occupies space is known as matter. And a ball is a good example. 2 marks, Musa.
Wow. Well done, Musa.
Thank you.
Okay, we continue.
Okay.
The ball has a mass and also is moving with a certain velocity. What is the product of mass and its velocity? Okay, Salma?
That is a momentum.
Very good. The product of mass and its velocity is called momentum. 2 marks, Salma.
Thank you.
Good. Since the ball is moving in straight line, how can we call its momentum? Yes, Musa?
That is linear momentum.
Excellent. Linear momentum is the product of mass and its linear velocity. Let us continue.
All right.
Is the linear momentum a scalar or vector quantity? Yes, Salma?
The linear momentum is the vector quantity. It has magnitude as well as direction.
Say it again.
The linear momentum is the vector quantity. It has magnitude as well as direction.
Excellent. 2 marks, Salma.
Thank you, madam.
The linear momentum is the vector quantity because it has magnitude as well as direction. We continue.
Let us continue, madam.
What will happen if the ball has a mass but it is not moving? Silence means... Okay. The momentum of that ball will be equal to 0.
Wow! Do you mean that the moving car also has the momentum?
Of course, you are right. But let us continue. Okay?
Yes.
The momentum is derived from physical quantity. What is the SI unit of linear momentum? Okay, Musa?
Well, the SI unit of linear momentum is known as kilogram meter per second.
Excellent.
Thank you.
The SI unit of linear momentum is kilometer per second. 2 marks, Musa.
Thank you, madam.
Well, is there any difference between moment and momentum? Is there any difference between moment and momentum? Okay, Salma.
Yes, of course, madam. There are some differences as well as similarities between moment and momentum.
Excellent. 2 marks. So, who can tell us those differences? Silence means... Momentum is the product of mass and its velocity,
Okay.
while moment is the product of force and perpendicular distance from the point of application.
Sorry, madam. Can you repeat, please?
Momentum is the product of mass and its velocity, while moment is the product of force and perpendicular distance from the point of application.
Okay.
I help you with the difference. What about the similarity? Those are derived from physical quantity as well as vector quantity.
I see.
We continue.
Okay.
Are these physical quantities have the same SI units? Yes, Musa, come on.
No. The SI unit of moment is the Newton meter.
Well done. Now, let me offer you a moment to relax.
That's great, madam.
We have completed the first round of our quiz and you did well.
That is perfect.
Are you ready for the second round?
Yes,
Yes, we are.
There are questions in the box. So take a question and ask your friend. Is it clear?
Yes.
Who will start? Okay, Musa.
Can you tell us other examples of the situation of momentum of the moving bodies?
Yes, I can.
Okay, go ahead.
These are the situations of the moving cricket ball,
Okay.
the table dragged on the floor, the drum of oil moving down the inclined surface, and others.
Very good indeed. 2 marks more. It's your turn, Salma.
Okay. What is the formula of calculating linear momentum?
The linear momentum is equal to mass times velocity.
Wonderful.
Thanks.
It's your turn, Musa.
Okay. An object of 2 kg travels on a level road at a constant velocity of 25 meters per second. Calculate the linear momentum of the body.
Repeat it, please.
An object of 2 kg travels on a level road at a constant velocity of 25 meters per second. Calculate the linear momentum of the body.
Well, it is given that the mass of the body is 2 kg and the velocity is 25 meters per second. We are required to calculate the linear momentum.
Excellent. What is the next step, Musa?
We recall from the formula of the linear momentum by using the given values of mass and velocity. Thus, linear momentum is equal to 2 kg times 25 meters per second.
Brilliant.
Thank you.
So, what is the result, Salma?
2 times 25, the result is 50. So the linear momentum of the moving body is 50 kg per second.
Excellent. Even we as bodies and matter, we have masses and moving with a certain constant velocity. Do you know that?
Yes,
Absolutely.
madam.
Now, think of moving car and suddenly stops. Is there any relation between momentum, time, and the applied force? Okay, Salma.
Yes, there is. But I think we are talking about the momentum change.
Well, Musa,
Yes?
do you agree with her?
Absolutely. As the body is moving faster, it seems to increase its momentum as well as force applied.
Excellent. 4 marks for everyone. You are so clever.
Thank you, madam.
Well, can we say that the applied external force is directly proportional to the velocity change?
That's right, madam. And not only the velocity, but also the time taken.
Exactly. And the external force is directly proportional to the rate of change of momentum.
Very good. I think there is no need to continue
Why, madam?
because you know everything about the second law of motion.
We need to continue, madam, because you are sharpening us.
Good. So tell me this.
Uh-huh.
What do you mean by rate of change of momentum?
That is the change of momentum over time taken.
Also, momentum change is the product of mass of a body times the velocity change.
Very wonderful. Do you mean velocity change is the difference between final velocity and initial velocity?
Absolutely, madam.
Why?
Because the external force is directly proportional to the rate of change of momentum.
And that is what is known as the Newton's second law of motion.
Very good indeed. Newton's second law of motion states that the external force is directly proportional to the rate of change of momentum. Newton's second law of motion states that the external force is directly proportional to the rate of change of momentum.
We are so happy with your quiz, madam.
I'm happy too, because all of you are winners. You got 28 over 30. Excellent.
Thank you,
you.
madam. We have to go now.
Good. See you.
See you next time. I'm so impressed with that discussion.
And me too, Salma.
Time is running and the temperature is increasing so fast.
That's right.
It is time to go back home now.
Absolutely. So let us go home.
Alright,
See ya.
see you.
Soma, soma mwana soma, uwe mjini. Soma, soma mwana soma, uwe kijijini. Soma, soma mwana soma, ukiwa na mahitaji maalum. Soma, soma mwana soma.
Alright, we were together in your discussion and I'm so happy. Hopefully, our dear listener has gained a lot through your discussion. Now, here are the questions about the topic for further discussion. Clearly, state the second law of motion. B. What do you understand by the term linear momentum? Give examples. What do you understand by the term linear momentum? Give examples. C. Join with your friend to identify the various situations in which Newton's second law of motion can be verified. Join with your friend to identify various situations in which Newton's second law of motion can be verified. Here is the end of this program, but you are so welcome in the next program. And until next time, bye bye.
Happy, 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 happy. Radio class. Happy, 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 happy. Happy, happy, happy. Radio class. Happy, 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 happy. Yeah. You can be a pilot.